Welcome to another MAAS Show and Tell. Peter is going to tell us about maximizing productivity with large language models, aka using AI to write your code for you. Go right ahead, Peter.
Thanks, Bill. I'm a senior web engineer on the MAAS team. Primarily, I work on MAAS UI, and I'm really excited today because I will be talking to you about maximizing developer productivity. By the end of the session, you should hopefully have a better idea of how you can use such a model to speed up your own work in various projects, but particularly in the area of code refactoring, as I will be sharing some of my own experiences and insights and share the example of how we migrated hundreds of legacy tests to React's testing library with the help of LLM. There's a lot to it, really, and for that reason, I'm going to keep it fairly high level for you to get a good overview. And I also would like to really encourage you to really think about these ideas as I go through them, how you could apply this to your own work. Okay, first, let's take a look at the challenges we face when refactoring large numbers of tests and the limitations of traditional tools. The process of refactoring large portions of code can be time-consuming, repetitive, and for that reason, also prone to human error, which affects our overall efficiency and code quality. Now, everybody seems to be talking about large language models nowadays, and that's for a good reason. I think they really do have an incredible potential and can be your superpower and automate away the repetitive work. With careful prompting, we can get the model to do simple coding tasks, which frees up developer time for more important, strategic, or frankly, more interesting work, and also reduces mental fatigue. While there are several code refactoring tools available, they sometimes fall short in specific scenarios. Such as when we need to transition between fundamentally different libraries, which is what we were doing. This is because this requires much more than a simple change of syntax, but it requires understanding of the underlying principles. And this is where LLM can help, because they really do seem to understand the context and can learn from examples. And as a result, we can transform repetitive tasks into efficient processes and boost the effectiveness of the entire team. Okay, so how can we actually use them? I will show you the process that I used. Let's call it LLM code refactoring loop. And this includes breaking down the problem and delegation, either to LLM or human developers. This involves grouping files into related clusters and figuring out the most effective order. And this is followed by engineering effective prompts and analyzing what information may be useful for the model for the best outcome, like in case of refactoring tests, whether we send the test itself and the component that's being tested. And then prompt testing, ideally on a small but diverse subset of components, as prompt may need to be adapted for each group, and automation scripts to apply the suggestions made by the model across the code base. And lastly, a combination of automated, such as unit tests and linting tools, and manual review of these results. This can be done by opening a pull request with files that pass automated tests and that don't seem to require further human intervention. And for files that have failing tests, placing them on a separate branch and delegating to engineers that will now have a much easier job and simply need to adjust the code slightly instead of having to start from scratch. And again, this will further inform the breakdown into clusters and the prompt itself, as you'll start to notice which things the LLM can do well and where it struggles. Now, the piece that absolutely none of it would work without is prompt engineering. And so I would like to share a few tips that I've personally found to be helpful in designing an effective prompt. Firstly, be prepared to not get it right the first time. Get ready for multiple iterations and a lot of confusion. Results can be very unpredictable and inconsistent, and it really does take time to get a feel for the model that you're working with. Next, it seems obvious, but the choice of words matters. Changing a single word that, for example, kind of means the same thing, but has a slightly different meaning can often alter the results dramatically. In order to leverage LLMs most effectively, it helps to also explain the underlying principles and ideas rather than focusing solely on the technical details. You've got to remember this isn't regular coding, and LLMs are capable of basic reasoning and figuring out things for themselves. And sometimes when the result still isn't what you expected, it doesn't necessarily mean that the model isn't capable of the right answer, but that you need to guide it using specific words and phrases to the right answer. And the single most effective thing that you can do to improve the result is to assign model a specific role, which you can do by saying, for example, act as a senior software engineer. Large language models generally have a limited context window, which basically means the maximum number of words they can process, and therefore being concise really matters as well. And it helps to narrow down and sharpen up your request. At the same time, it's counterintuitive, but sometimes the opposite is true, and you need to repeat important pieces of information, which I will explain later on in the presentation. You can also teach the model things that it didn't know initially, and give the model time to think, which sounds confusing at first, but think about the way you think yourself, and you usually, well, a lot of people have an inner dialogue, and you can do a similar thing with the model and ask it to reflect on its own answer, and then in the next message to update the original answer based on the reflection. And funnily enough, a model can often find its own mistakes. Okay, so what does it mean in practice? Here is the prompt that I started with when I began to explore the option of using LLM for refactoring tests in MAAS UI. That goes migrate submitted tests to testing library React, and the original legacy enzyme test itself. And in the test, as you can see, we are looking for an A element, whatever that means, in a wrapper, and checking that it contains a specific string. And here is the first results that I got back, which isn't ideal, but already looks promising. It got many things right that I didn't even need to explain. Like, for example, it understood that the A string is actually an HTML anchor tag, and it can use get-by-role link query to find it. Also, it knew which assertion methods to use from the new testing framework. But as you can see, because LLMs often try to be helpful, they tend to over-explain everything, which really isn't what we want to do here. So let's try to narrow down the request and make sure we only get code back, and add only code in your response. It followed the instruction, and we indeed did get only code back in the response, but now it simply returned the explanations as comments within the code instead. Looks like we need to be more precise. Let's try to fix it and ask to not add any comments. And there you go. This prompt works in this particular case, But to make sure that it works across the entire code base, let's make a few additional improvements. Like use a custom input path. This is something specific to MAAS UI. Also, something I mentioned previously, assign a role of a senior developer. And believe it or not, adding word class made a big difference in quality. Again, word and phrase choice is really important, and you need to guide the neural network in the right direction. As you will be touching various concepts, it will alter the result. There's one more thing I tried, which had somewhat surprising results. Instead of simply saying migrate submitted test files, we could say your purpose is to migrate submitted test files. For some reason, AI was much more committed to providing the best result possible. And again, another incremental improvement in the quality of the results. One more thing, let's try to explain the best practices that we'd like to be followed in our tests, like using specific query methods, get by, query by. And generally, things were going really well at this point. I was moving in the right direction and getting better and better results at every step of the way. But unfortunately, at this point, AI started hallucinating, which is a known concept, to try and follow the request, even if it didn't make sense in that particular file. It was adding assertions for presence of elements, even if there wasn't anything to check. So this needed some work. I solved it by expanding the prompt even further and added, do not add screen get by queries if there are no checks for presence in the original test. Okay, I think we're almost done. But one thing that was very common in legacy tests was an assertion that a component is in loading state. And such loading state was usually indicated by a spinner component, which presence was being tested in those tests. So I had to explain that the spinner component used in tests previously actually renders loading text, which is what we want to test now. Spinner renders loading text, which you can select using screen get by text query. And again, consistently better results. A few additional details, and here you have it, the final prompt, which is significantly longer, more detailed, but most importantly, more effective than the initial prompt. And so having went through this process, we had a prompt that worked for the vast majority of cases. And as a result, one thing I have to mention is that the test migration was a fairly important piece of work in MAAS UI, as legacy tests were blocking React framework upgrade, which included a number of performance improvements for the users. But using this technique, the vast majority of files have been successfully migrated with minimal or no human intervention. I mean, all files required at least a code review. Having integrated LLM into the process, we managed to migrate hundreds of remaining legacy MAAS UI tests to a new framework in record time. Something that would, and here I quote, take forever otherwise. Let's go back to the previous example to really see the difference. So this is the raw output from the LLM, obviously slightly simplified for the purpose of this presentation. And all that was required in this case to complete the migration of this particular file was changing a single line of code. I repeat, in this case, we went from an entire file to only a single line requiring human intervention, which I don't know about you, and if I should start to worry about my job, but I was really impressed the first time I saw this. One last piece I'd like to cover before I finish is the fact that manually copying and pasting strings of text between the LLM and source code is obviously suboptimal. As I mentioned in the LLM refactoring loop, important piece of the puzzle was automation, which not only saves time, but also reduces the risk of human error. And how I handle this, long story short, is I created a simple Python script that would search for files, test files in particular, using a regular expression, send those files, including the prompt I designed to the LLM via the API, and then save the output directly in your local repository. Then in that very repository, run automated tests, including linting. And then only for failed tests, make another attempt, including the source file of the component being tested in the prompt this time around. Then next step was delegation to developers, which I handled in the following way. Created a Git branch with a test migration completed by the LLM, then broke down or updated tests to tasks which were delegated. And then developers used that LLM output as a starting point of the work, significantly increasing their speed of delivery. To summarize, we've explored the power of language models in enhancing team effectiveness for code refactoring. We've learned how to harness the capabilities by creating effective prompts, continuously refining and adjusting them for optimal results with LLM code refactoring loop, and ways of automating the entire process. We've also learned how integrating language models can lead to substantial improvements in team efficiency, code quality, and a reduction in manual repetitive work. I also use a real-world example demonstrating how we managed to migrate hundreds of MAAS UI tests from Enzyme to React testing library in record time. Thank you for your attention. I hope you found this session valuable. And what I really do hope is that you got excited about the possibilities of using language models in your own work. Also, I think we have time for some questions, if there are any.
So I would actually, sorry, Nick, I just jumped in. I would actually, I've done some of this with Emacs Lisp and Python, basically writing new code. And what I discovered is when you give LLM a role, you have to be careful how you define that role. LLM is not a great writer of Emacs Lisp. It really struggles with the language. I'm not sure why. So you have to take it piece by piece. Okay, write me a function that just does this. Now, take that function and make it do this. And then, of course, there's things you have to debug. So I've found that a lot of manual debugging steps by me really have to go in, or I have to go find the error and say, hey, you missed this. Oh, you're right. I totally missed that. So be very careful because it takes you very literally. And if you give it a specific person or a specific persona and it can get information on that person, it's going to behave like that person would rather than giving you the answer you're looking for. So I guess, I don't know if that's a question or just an observation. Other questions around the loop here?
Yeah, I'd like to ask something actually. So obviously it's very powerful in terms of code refactoring, especially in the context of that test migration. I was wondering what the sort of impact of it is on implementing brand new features from the ground up, and if you've tried that at all and how it might make that process easier.
Depends on the complexity of the feature. But in general, it's not great. What I would say, it can be helpful in doing things that are repetitive and things that are standardized across the industry. So, things that when you create a new React component, boilerplate code, that kind of thing, it can make you faster, but I definitely, at least not yet, wouldn't trust it to write an entire implementation for a feature, for example.
Thanks.
It is really good at generating different ideas. For example, how can I implement X, Y, and Z? And then it just goes and generates a list of different options. And, yeah, it can still be valuable, but it's not a replacement for a real developer. Thank God, not yet. There is a next level which you can go to when you start using lang chains and providing, more context. For sure.
I was going to actually speak to your question a little bit, Nick, because I've actually done that some, writing some code. But I find that, I think I described it earlier, but you have to literally do it like you're getting a very junior developer. Write me a function that will do this.
Yes.
Now, encapsulate that function. Now, don't change that function, but write me a function that will use that function to do this. You can't give it a big objective because, for example, with Emacs List, it just makes up functions that does what it wants. And then you have to tell it those functions don't exist. And it says, well, it doesn't. Well, here it is. And before you know it, you have like 4,000 lines of Emacs List, which is way too many. It's bloated, it's slow, it's poorly designed. So you can't give it, at least currently, you can't give it these full design problems. You have to do it in small pieces. It's great at writing little macros for me in Emacs List, but it's not great at writing a piece of code. For example, I asked it to write functions that would go get a fortune and print them in my message of the day, no problem. And I asked it to give it some specific requirements for that fortune. There's certain kinds I like and don't like. Then I asked it to write the BSD calendar program. And what it wrote is completely useless. Huge, long, and doesn't work right. So keep it small, lead it through a piece at a time. Sorry to butt in on your presentation, Peter.
So first of all, thank you very much, Peter, because it was very interesting. And at the end, it's a success story, right? So it's very nice to see how AI supported us to such achievement, which is huge. But having said that, from my experience, I tried to learn a little bit how it works. And at the end, given that it only construct the response according to the most probable next word, it's important to understand what it can do and what it can't do. So, for example, you can ask AI to factorize a number. So you can ask ChatGPT to do this because it will just predict the most probable next number. And if you try it, it doesn't work. As well as for code generation, sometimes it works great, but at the end, it really depends how it fits inside your solution. So, for example, if you ask to write a question, a function, a complete new function, and you don't ask AI to handle exceptions, for example, you might do big mistakes, right? Because it's not copy and paste. So as you said, it's really important to formulate the question and give a lot of context in order to generate something that is useful. But yeah, I simply think that sometimes, not sometimes, it's always, the human interaction is always very important. So without a clear understanding of the result and the response that the AI gives, it's dangerous. So without consciousness, it's really dangerous to use such tools. But as I said, it's great to see a success story because at the end, the result was great. So just my 2 cents.
Peter, do you find it to be more like a really intelligent Google than an actual coding partner?
Precisely. What I found, for example, as well is, which you kind of touched on, is AI is really bad at numbers, certain types of reasoning, because it's only predicting the next word in a sequence. Like, for example, the stable diffusion models that predict the next pixel that generate beautiful images, they really, really struggle with the number of fingers, for example, because they don't really have a concept of a number of that, or that a human should have 5 fingers. Right? It is a tool, limited tool, but depending on what you need, it can be really, really helpful.
Other questions from the crowd, comments? Incredulity, wanting to get Peter to sign up to teach you this? Well, hearing nothing, thank you, Peter. That was a great presentation. It is a topic of interest to a lot of people. Remember to add your questions and comments below this presentation. We hope to see you next time.